Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Minister of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I would like to discuss the question bank problems. In Module 2, the topic is differential equations and this is Part C problems. Now I will go the problems one by one. And these are very short answer and some problems we have to solve with pen and paper. So what is the Wronskian condition for the functions? The Wronskian condition, W-R-O-N-S-K-I-N. The Wronskian condition is used to find whether the given functions are the linearly independent or not. What is the Wronskian condition? At phi1 of x and phi2 of x are two functions of x, then to check whether the given functions are linearly independent or not, we use the Wronskian condition that is denoted by W of phi1, phi2. That is determinant of phi1 of x, phi2 of x, and phi1 dash x and phi2 dash x. If this determinant value not equal to 0, then the two functions are said to be linearly independent. If this is 0, then we say that the two functions phi1 of x and phi2 of x are linearly dependent. So based on this, we find whether the given functions are linearly independent or linearly dependent. That is W of phi1, phi2, determinant of this one. That is the first question. Now second one, write the solution of 4d square minus 4d plus 1 of y is equal to 100. Write the solution of 4d square minus 4d plus 1 of y is equal to 100. So clearly this is the second order differential equation and right side is a function of x 100 into some e power 0x like that. So the solution will be the combination of complementary function and particular integral. So here the complementary function can be calculated by using the function 4m square minus 4m plus 1 is equal to 0 and this is called the auxiliary equation. Then this is 2m minus 1 whole square is equal to 0. I am expanding 4m square plus 1 minus 4m is equal to 0. Or 2m minus 1 is equal to 0 or m is equal to 1 by 2 comma 1 by 2. There are two factors 2m minus 1 0, 2m minus 1 0. The roots are the real and equal. Therefore, the complementary function or we denote by yc is equal to c1 plus c2x of e power x by 2. That is the first part of the solution. Clearly, this equation solution will be the complementary function plus particular integral. The first part complementary function is c1 plus c2x into e power x by 2 because the roots are real and equal. Now, the particular integral. What is the particular integral? Yp is equal to 1 by 2d minus 1 whole square of 100. This can be written as 2d minus 1 whole square of yp means 1 by this one is equal into 100. So when it is 100, we can go for the first method, e power ax, particular integral shortcut method. First one already we have discussed in the regular syllabus. And this is 100 constant, e power 0x into 1 by 2 into 0 minus 1 whole square. If it is not 0, just you have to substitute d for 0. So d plus 0 raste 0 minus 1 whole square. So this is 100 into minus 1 whole square, that is 1, that is 100. This is the second part of the solution. Therefore, the required solution y is equal to the complementary function plus particular integral. So what is the complementary function? The first equation c1 plus c2x of e power x by 2 plus 100 is the required general solution of the given differential equation. This equation is in the form f of d if y is equal to q of x. The solution will consisting of both complementary function and particular integral. The solution will be c1 plus c2x into e power x by 2 plus 100. So first two problems over. Next, solve the differential equation d power 4. Third problem, d power 4 minus 16 of y is equal to 0. So the right side is 0 means particular integral 0. Only the complementary function will be the final solution. So we write the auxiliary equation as m power 4 minus 16 is equal to 0. Or I can write it as m square minus 4 into m square plus 4 is equal to 0. A plus b into a minus b. M square into m square, m power 4 minus 4 into plus 4 minus 16 is equal to 0. So m square minus 4 0, m square plus 4 0. So m square is equal to 4, m is equal to plus or minus 2. And here m square is equal to minus 4 or 4i square. So m is equal to plus or minus 2i. Here the roots are complex roots. Here the roots are real roots. Therefore, the solution y is equal to c1 e power 2x. The roots are plus 2 and minus 2. First I am writing for the real roots c2 e power minus 2x plus e power 0x into c3 cos 2x plus c4 sin 2x. This is the required solution of the given differential equation. These roots are plus 2 minus 2, c1 e power 2x plus c2 e power minus 2x plus r minus 2i, c3 cos 2x plus c4 sin 2x. So because this is a fourth degree equation, fourth order equation, so there exist 4 constants c1, c2, c3, c4. That is the third problem of the given question bank. Similarly, solve the fourth problem. This is also very simple. Already we have done all these problems in the regular classes. D square plus d of y is equal to 0. So what is here the auxiliary equation? The auxiliary equation is f of m is equal to m square plus m. So now the auxiliary is equal to 0 or m into m plus 1 is equal to 0 implies m 0 comma minus 1. So clearly it is a second order equation. There are two roots. Therefore the solution is c1 y is equal to, what I can write here? The solution is y is equal to c1 e power 0x plus c2 e power minus x. Or I can write it as c1 e power 0x1, c2 e power minus x plus minus x. X. This is the general solution of the given differential equation. So now we have solved the first question like all the 4 questions. Now I go for find the particular value of 1 by d minus 2 d minus 3 of e power 2x. The particular value of fifth question 1 by d minus 2 of d minus 3 of e power 2x. We have to find particular value of this function. So we have to operate 1 by d minus 2 into d minus 3 on e power 2x. So for our convenience, I am writing this into partial fractions 1 by d minus 2 or 1 by d minus 3 minus 1 by d minus 2 of e power 2x. Can I write? I am writing d minus 2 minus d plus 3. d cancel, 3 minus 2 1. I am splitting this 1 by d minus 3 minus 1 by d minus 2 of e power 2x. So on simplifying, you will get d minus 2 in the numerator minus d plus 3. d cancel 1 by this one. Or 1 by d minus 3 of e power 2x, and on second function on operating e power 2x with 1 by d minus 2. So how you have to operate 1 by function of d of e power x? Just replace d by 2 if it is not equal to 0. That means what? E power 2x by 2 minus 3 because it is not equal to 0. If it is 0, then what is the formula? 1 by d minus a whole power k of e power ax. That means when you replace d by a, the value 0, then the formula will be x power k by k factorial into e power ax. So it is also like d minus 2 whole power 1 e power 2x. So the value is x power 1 by 1 factorial into e power 2x. So the value is e power 2x by minus 1. So minus e power 2x minus x into e power 2x will be the required particular value of this function. So you have different methods, shortcut methods. 1 by f of d of e power ax, and other one is 1 by f of d of sin bx or cos bx, 1 by f of d of x power k. So just to see which function was given in the given problem, and according to that you apply the respective formula. Now what is the sixth problem? Find the particular value of 1 by d square minus 1 of 1 by d square minus 1 of sin 2x. So 1 by d square minus 1 of sin 2x, it is 1 by function of d of sin bx. Just to find this, we have to replace d square by minus b square. Here b is equal to 2. Here b is equal to 2 because the sin bx notation. Just to replace d square by b square, that is 1 by d square by minus b square means minus 4 minus 4 minus 1 of sin 2x or minus 1 by 5 of sin 2x. Very simple. Minus 1 by 5 of sin 2x will be the solution. Next, what is the seventh one? Write the solution of d square y by dx square minus 5 dy by dx plus 6y is equal to 0. So see the solution of the seventh problem. So clearly it is a second order equation. I can write in operator form d square minus 5d plus 6 of y is equal to 0. So here what is f of d? F of d is a function of d, that is d square minus 5d plus 6. This is the function of d. Now the auxiliary equation is f of m is equal to 0, that is m square minus 5m. Just replace d by m, that is m square minus 5m plus 6 is equal to 0. Now based on the roots of the equation, we write the solution. So m square minus 3m minus 2m plus 6 is equal to 0, or m into m minus 3 minus 2 into m minus 3 is equal to 0, or m minus 2 into m minus 3 0, or the values are m values are 2 comma 3. The roots are real and distinct. So the solution will be in the form c1 e power 2x plus c2 e power 3x. Just clearly there is no particular integral here. The complementary function will be the general solution of the given problem. Now the eighth question. Solve the differential equation d square plus a square of y is equal to 0. Right side 0. Right side 0 means only the complementary function will be the final solution. So here what is f of d? D square plus a square. The auxiliary equation is f of m is equal to 0. That is m square plus a square is equal to 0. M square is equal to minus a square, or m square is equal to minus 1 means I square a square. So the m value is plus or minus ia. The roots are real and complex roots. There is no real root here. It is in the form alpha plus or minus I beta. Then what is the complementary function? E power alpha x into c1 cos beta x plus c2 sin beta x. This is the notation. So here alpha 0 and beta is equal to a. Then the general solution y is equal to e power 0x into c1 cos ax plus c2 sin ax will be the solution of the differential equation d square plus a square of y is equal to 0. Similarly, ninth problem. All are only the complementary functions, no particular integral. Complementary function itself will be the general solution of the given equation. So what is the other equation? Y double dash. What is the equation? Plus y dash minus 2y is equal to 0. Y double dash means d square y by dx square plus dy by dx minus 2y is equal to 0. So in operator form, what I can write? D square plus d minus 2 of y is equal to 0. The auxiliary equation f of m0, that is m square plus m minus 2 0. So what are the roots of the equation? M square plus 2m minus 2 is equal to 0. So 2m minus m plus m. 2m into minus m minus 2m square. Or m on taking out m plus 2 minus 1 on taking out m plus 2 is equal to 0. So the roots are, factors are m minus 1 into m plus 2 is equal to 0. So the roots are 1 comma minus 2. Therefore the solution or the general solution, the solution is given by y is equal to c1 e power x for the root 1. And for the root minus 2, that is c2 e power minus 2. That will be the required solution of the given differential equation. Similarly, do the 10th problem. Find the particular integral of 1 by d square plus 2d is equal to 24x. I will write here 1 by d square plus 2d of 24x. So 1 by d into d plus 2 of 24x. So I'm writing in the numerator 2 take outside, 1 by 2d of 1 plus d by 2 of 24x. Just 2 take outside, 1 plus d by 2. Then 1 by 2d of 1 plus d by 2 whole power minus 1 of 24x. If it is x or x power square, x cube, x power k form, then we have to write 1 by f of d in the form 1 by 1 plus phi of d notation by taking out the lowest degree term, and then use the binomial expansion to find the particular integral. So 1 by 2d of 1 minus d by 2 plus d square by 4 minus d cube by 3 plus so on of 24x. So it is 1 plus x whole power minus 1 expansion. 1 minus x plus x square minus x cube, like that. So here 1 minus d by 2 plus d square by 4. X cube means d cube by 3. But here we required only up to the term containing x power 1 only. So on multiplying 1 by 2d, 1 by 2 to 12s are 24. So 12 we can write like this, 12 into 1 by d, and multiplying 1 by d inside. First term 1 by d, second term 1 by 2, next plus d by 4 minus d square by 3 plus so on of x. So 12 into 1 by d of x. 1 by d means integral of x. 1 by d of x means integral x dx. That is, first value is x square by 2. Second value 1 by 2 into x, that is x by 2, plus d of x under 1 by 4, d of x. D of x means d by dx of x, that is equal to 1. So 1 by 4 minus d square higher degree terms all are 0. That is 12 into x square by 2 minus x by 2 plus 1 by 4. Or what I can write? 2 6 are 12. 6x square. 2 6 are 12. 6x. 4 3s are 12 plus 3. So the value will be, I can write, this is equal to, what I can write? 6x square minus 6x plus 3. That is the required particular integral of 1 by d square plus 2d of 24x. 6x square minus 6x plus 3 is the general solution of the given equation or particular value, whatever he asked. Then what is the general solution of the higher order differential equation? This is general definition. Higher order equation is in the form dn y by, I will write, general solution. What is the general solution of this equation? So generally we write the equation in the form dn y by dx power n plus p1 dn minus 1 y by dx power n minus 1 plus so on plus pn into y is equal to 0. This is the right side sum function q of x. So this is the general form of the higher order differential equation and which is of degree order n. So to solve this equation, first we have to write in operator form d power n plus p1 d power n minus 1 plus so on plus pn of y is equal to q of x. And this is in the form f of d into y is equal to q of x. And the general solution of this equation will be the complementary function plus particular integral. So the complementary function can be calculated based on the roots of this equation, and particular integral will be 1 by function of d of q of x. So we have various methods to find the particular integral as a shortcut method and common procedure for complementary function. Based on the roots, roots are real, distinct, and roots are complex roots and complex and repeated. So based on that we write complementary function, and based on the function, right hand side function, it may be e power ax, or it may be sin bx or cos bx, or it may be x power k, or it may be e power x into sin bx, or x into v of x. Based on the method, based on the function on the right hand side, we follow different methods. We have the general procedure also, but these are the available shortcut methods to find the particular integral. So the sum of 2 is the general solution of the given differential equation. So the last problem, find the particular values of 1 by d square plus 9 of cos 3x. 1 by d square plus 9 of cos 3x. So in this case, the method of finding the particular case, sin bx or cos bx, that is the notation. Just you have to replace d square by minus b square, minus 9. If you supply minus 9, it will be 0. So the formula will be x by 2b sin bx. The formula integral cos means sin will get. The function x by 2b, b means b square is 9, b is 3. So the value is x by 6 into sin 3x. Similarly, 1 by d square plus 16. What is the formula? Is 1 by d square plus b square of sin bx is equal to minus x by 2b cos bx. If it is cos bx, then it is sin bx with positive sign. That is the formula. So 1 by d square plus 16 of sin 4x. Here also when you replace d square by minus 16, it will be 0. So the solution will be minus x by 2 into 4 of cos 4x. Or this is minus x by 8 cos 4x is the particular value of 1 by d square plus 16 of sin 4x. Similarly, 1 by d square plus 9 of cos 3x is x by 6 of sin 3x. So these are the some problems discussed in the module number 2 of the section C. Section C all are definition and terminology. Definition and some short problems. So those we have discussed nearly 13 problems. The definitions also we have discussed in this session. So these have been taken from the we know that it is the question bank of the course Differential Equations and Vector Calculus, and the regulations is BT 23, and which is published by the Ministry of Aeronautical Engineering. And with these few problems, I conclude my lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.